Okay, so it's going to have 6 questions. So this is being recorded. I'm also going to type this up into Schoology as well. But you can take notes if you like. 6 questions, 10 points each. So core 60 points total, right? And also it will be scaled to 100. So it's the same weight as all the other tests. Okay. So we have now we'll have had 5 tests by this Thursday, by tomorrow, and everyone's scaled up to 100. So scale to 100 points. Just like all previous tests. So what this means is that these questions are going to be pretty lengthy. Like, I do anticipate you spending about 8 to 10 minutes per question. So they're not going to have like necessarily multiple parts. Just going to be deeper thinking questions. So any calculator allowed, but no Desmos. Actually, I'm not sure how Desmos would help, to be honest, but I think just avoid the hassle of trying to set it up because it always seems to be a pain in the ass. Any calculator allowed, but no Desmos. 60 minutes, as usual. So 60 minutes. Formulas provided. It'll be 5 formulas I'll give you. What will they be? I'll give you that one. What's that going to be, guys? Yeah. Yep. I'll give you this one. Marie. Thanks. Appreciate it. Obviously, what's this one here? Second one. Dot product with find the angle between 2 vectors, right? Um, you could use it if you want to. It could help you, but you won't need it. Yeah. You could use it if you want to. Also, De Moivre's theorem. You guys remember what was De Moivre's theorem? You guys remember? What do you use it for?
Root one?
It's not the root one, actually. It's when you raise it. If I say do 3 plus 2I raised to the 8th power, you could multiply 3 plus 2I 8 times if you're crazy. Or you could use De Moivre's theorem, which tells you define the R value, define theta, and then you do I actually remember it.
Thank you.
And then you figure out what n is and you multiply it out.
It's the magnitude
Here.
power of that number, and then you multiply that.
Correct. Yes. Yeah, De Moivre's. Thank you, Teddy. Yeah. Oh, the parking is crazy because of the quality of the seat.
Why do they have your spots blocked?
For the parents' part.
Oh,
Because all the
I'm outside of Dollinger, like actually, like.
Yeah, yeah, I just got to do anyway, that's the loss theorem. So anyway, I'll give that to you. And then the roots also. So the roots is not exactly De Moivre's theorem technically, but it's kind of close. Okay, so those forms will be provided. Um, Also, no mole choice. So just seen as no mole choice. And there's no graphing. So it's all just one part. Again, I will post this to Schoology too. I'll put it as under test number 5. And this is being recorded. So again, 6 questions, 10 points each, 6 points full, scale to 100, just like all previous tests. Any calculated, no Desmos. 60 minutes, no mole choice, no graphing, formula provided, no graphing questions, I'm going to say. No graphing questions. There we go. Yeah, and let me see if this is a screenshot too. Might be a good idea. Cool. Okay, so those are the general details. Now I'm sure you guys want to know the finer details, right? Here are the finer details. Okay. There will be an airplane question. Not a boat, not a truck, not a car or bus, airplane. Airplane with wind and bearing. And the pack I just gave you guys have lots of practice on that. Lots of practice. So you have plenty of practice there. Of course, it's going to involve vectors, right? So you'll need to make a vector, work it out, add the vectors, whatever. Magnitude, all that fun stuff, direction. Okay, next one's going to involve forces. And forces, so let me rephrase that actually. Several forces acting on objects. That will also involve vectors. And ultimately, you'll have to find the work done. So the way it's going to work, it could be like, say, for example, I'm trying to think of good objects here. Okay, just table, I don't know. So let's say I'm pushing this table, Marie's pushing the table, Luke is pushing the table, right? But I'm just stronger than them. So I'm just really upset. I don't know. So I just push it that way, right? So first you have to figure out the force, the overall force, right? Like you got my force, you got their force, right? So you got to figure that out. Then also, you got to figure out the distance that the tail travels. So I'll tell you, like it starts at this point, goes to that point. So you guys know how to find a vector when I give you 2 points, the starting point, the final point, right? So you make a vector for the distance and then multiply, do a dot product with the force. So I'm telling you right now, the question is, it's going to be I'll be more creative, obviously, when I finally get to writing it. But yeah, it'll be like, multiple forces acting on an object. So you got to find the overall force, the resultant force, right? Just, get vectors for each of the forces. And I'll give you the direction. I'll say, this force is acting this direction with this magnitude and blah, blah, blah. Once you get the resultant force, then figure out what the distance vector is. I'll tell you this object is at this point and now moves to that point and do the dot product after that. So it should be very straightforward. Just more matter, just calculation, really. Lucas said.
I forgot how to find the result.
We just add all the vectors.
Oh,
Yeah. So like say for example, my force is 100 newtons and I'm pushing at like 70 degrees, right? So just do 100 cos 70, 100 sine 70.
and then you find the vector, and then I'll do that for
And then let's say yours is like 50. Okay.
Worse.
Because you're not as strong as me, so 50. Just kidding. 50. And let's say your angle's at 220. So you can do 50 cos 220, 50 sine 220.
Oh, and then I can find the vector.
And then say Maria's like, no, she's the strongest of all of us. So she's 200, right? And she's going like maybe 40 degrees. Then you do that. Add them all up and find the magnitude, right? Yeah. Yeah. So this can be very straightforward. Yeah. Of course. Yeah. Of course. Yeah. And then you make a vector out for the distance, right? So I'm just telling you right now what I'm going to do. So the things that the packets I gave you guys, well, you'll practice that because there's questions like that, right? So you should be fine. Angle between two vectors. So that's going to involve a dot product. However, with a twist. And you'll see. I'm not going to say what the twist is. Actually, I will tell you a little bit. It's going to involve some triangles. I'll just leave it at that. So it won't be that. If any information I think you would need, I would provide it for you. Like say for example, like area of a triangle or something like that. I'll provide that. But yeah, with a little twist. You'll see. It's not going to be something you won't know. Like don't worry about it's like, oh well, I didn't know this. No. Whatever outside information you need, I'll provide it. But what you do need to know, the core skill is the dot product, right? And find the angle. But I just you haven't seen a question that be exactly like how I'm going to design it. So I just want to just give you a little bit of a heads up. Like, but that's what I'm doing fewer questions, so you have enough time to kind of think it through. Okay, number 4. Next one will be simplify an expression with complex numbers. Simplify expression of complex numbers. Excuse me. And it's going to be a combination, just so you know. A combination of operations. So what I could do is I could say, I'll just run the board because it'll be easier. I can say this. Rewrites in A plus BI form. I think something kind of crazy like this. However, you have your formulas, right? You'll have, ways you can do this. Like we have a formula for this, right? That's the Watt's theorem. And then you can multiply and then divide afterwards. So you have all those things out there to help you. By the way, you'll have a TI-4 calculator. Do you guys know how to verify this in the TI-4 calculator? I'll show you right now. It's very simple. I is actually built into the calculator. Let me clear this for a moment. So if I were to work out that problem, I'll do 1. Sorry, this is 3. My apologies. 3 minus 2. Now, second decimal point is where I is. That's where it is. Second decimal point. Raised to the 8th power. I think I may have shown it to you guys, but I don't remember. And then multiply it to 1 minus I. So you could totally just do this and give me the answer. I'll give you a point for the answer, not give you the rest. So you have to show me the work. Okay, that crazy number, fine, whatever it is, right? Divided by 1 plus 2i. Fine, there you go. So you can verify the work within a matter of seconds, right? Just to make sure you got it right. So that might, I think the reason why I like that to allow the calculator here is give that confidence, right? Like, okay, cool, I got this, right? I did the calc, but you guys show me the motions, like, oh yeah, let's use Watt's theorem. Let's, then whatever that is, let's foil it with this. Okay, great. Okay, then do you guys know how to get rid of the I here? What do you do about top, bottom? Conjugate, exactly, right. Yeah. So, so just a kind of I'm giving a heads up so there's no surprises. But just be prepared. So like the packet I just gave you guys, that front page, you'll have plenty of practice. So I'm not giving you a problem exactly like this. I'm just telling you what to expect. But individually, as parts, yes. All I'm asking you is put all those parts together on the test. That's what I'm asking you to do. Charlie, go ahead.
Are you use like nicer numbers that don't produce like these wacky decimals?
Yes, that's why it takes 2 to 3 hours to write a test. Because when I do see wacky numbers, I have to go back to the drawing board. And so I usually try to figure out what I want my answer to be, and I work backwards. So I will do that for you guys. If you guys want, I can make every answer 6, 7 too. If you want me to do that, 6 plus 7 I. No, no. I will. Yes, I will do that for you guys because that is kind of nasty. I agree. All right. The 5th question. Solving an equation by finding all roots. Now, what does that exactly mean? I'll give you an example.
Is it gonna, well, I don't know if you can say this, is it gonna be a unity level?
Yes, exactly correct. No, I will say it. I have no problem disclosing that. So so complex. So, and by the way, your calculator can verify this. I'll show you how. So, yeah, I could say, 8x to the fourth power minus, I think here, 128. Do something like that, right? And then, of course, we could do this. And of course, it's the fourth roots. However, we know I know it's gonna be 2 and plus or minus 2. I know I'm gonna get that. There's also 2 other roots that are complex. And you have to use that special formula, right? The one with the K, right? We talked about that. The 2 pi K part is like, I can't remember now. But it kind of look like this is like cosine theta plus 2 pi K. You guys remember that, right?
Yeah.
Plus I sine, that other junk, right?
We're gonna get that one too, right?
Sure. Why not? Now, of course, I'm getting that one. That's the hardest one to remember, right? And of course, I'll get that to you, right? But it's gonna be designed like that, just so you know. So again, I'm disclosing what I'm gonna ask. So we haven't seen problems exactly like that, but have you done that skill? 100% you have. You totally have done the skill. Just telling you what to expect. And the reason why I'm kind of disclosing this is to kind of train you as you guys move forward toward Deep Calculus BC, where you're going to see questions kind of like this, but don't freak out because it's really the skill you've always done, right? So, Marie, go ahead.
For this like particular one, when you get the x equals like 16, like what do you do? What do you do with that?
So what you do is you think of 16 plus 0i.
Okay, so you write it.
So that's your A and that's your B. So then you got to find your R value, which is this, right?
How does that become 16?
Because there's no imaginary numbers. Because you're trying to find the fourth root of 16.
Okay,
Because that's your complex number.
okay.
Think of that as a complex. So actually, Maria asked a great question. How do you treat this as a complex number? That's how you do it. So then R is going to be just 16, obviously. What's your theta going to be, by the way? If you graph this on a complex point, what's your
0.
0? Yeah, exactly. And of course, n is 4, right? So you're doing 4 roots. So then you just plug away with this. And actually, I think it was kind of crazy. Yeah, I think I got it right. Right? Nth root of R. So it'll be 2 times cosine 0 plus 2 pi K over 4 plus I sine 0 plus 2 pi K over 4. And then you have to do K equals 0, K equals 1, K equals 2, K equals 3, right? You got to do all those iterations. So, but that takes time. So that's why I'm only asking for your questions. Yeah, looks good.
On this, also the x to the fourth minus 16, if I actually look at the 16 from both sides, then I top her up, that actually the wrong way to do it.
Because like in this packet.
Things that I can't find.
Wait, so say again. Sorry, I lost you.
Like, you know how step x to the fourth is equal to 16?
Right,
If I like subtract the 16 on both sides, I got
Subtract the 16.
x to the fourth minus 16.
You mean divide by, you mean divide by 8? I'm confused.
No, like if I turn it into x to the fourth minus 16.
Oh, you factored it. Got it. No, you still be fine. You have x squared plus 16. I mean, obviously, yes, you could do that technically because you have x squared minus, right. I see what you're saying. Because you have x squared minus 4 and x squared plus 4. And of course, you get x minus 2, x plus 2. The x squared plus 4 is going to be plus minus 2i. So you don't technically, but that's why I'm going to give something not as easy to do that way. I know what you're trying to do. You're trying to find another way so you could avoid. I'm not saying you want to avoid it, but what you just said, you would avoid this, right?
Yeah.
Because you could just solve it by factoring this down. But I'm going to give you something that's not going to be that simple. Because I'm going to force you to use this. Yeah. But I'll just give you an example of how I'm going to ask it. So, yeah. Okay, the last one. You guys may not like me for this. Please don't tear me apart.
No, not the.
Yeah, I got to start training for finals. However, okay. There's no graphing.
So we'll have to like graph like. Yeah.
There's no graphing. Study old tests. I will copy/paste an old question and just change the numbers. And I'll give you some examples from one of your tests.
What was your?
Trig. Okay, it could be a general solution from trig. General solution for a trig equation. Sinusoidal modeling. And I will provide the identity if you need one. If you need that, I will provide the specific identity next to the problem.
One of those.
Or there's more.
Isn't that graphing?
No, going to graph trig.
Yeah, but it's not a non-calc question, put it that way. It's graph, but it's not something where a graphic calculator would like. I'm not going to ask you to graph like a tangent function because you just punch in your calculator. That's what I meant by that. Yeah. Which we just had in our last test. I will say this. These are the questions I'm going to be asking on the final exam. I am retooling the final in some way. So I'm actually kind of giving you a heads up of what to expect in the final exam. I'm asking these 10 questions in the final exam, just so you know. And there'll be 2 questions on the discovery unit on the final exam as well. You can probably imagine I'll probably do a complex number question in the final exam and a vector question in the final exam, right? So yeah. So I'm kind of so I will just tell you right now, it'll be any one of those 10. It could be any one of those 10 questions. So I kind of narrowed it down so it's not so wide open. Like it's something that's going to be that's appropriately a 10-point question. And I actually did look at the old test this morning, and several of those were 10-point questions, or roughly around that ballpark. So look at your old test. If you guys want, I'll post all the old tests and all the solutions so you can just look at it. I don't want you guys to like stay up all night doing all these problems. You should just be able to look at it and see, yeah, I got this. I remember this. So that's what I'm asking you guys to do. So, and let's get you ready for finals. So that's the whole point of this. So to get you start thinking about it. No, don't pull an all-nighter. Don't do that. You need sleep. You need to sleep. But that's what's happening there. So, but I will provide enough information like formulas and whatnot. So you have that at your disposal. Okay. So that's all I want to say about the test. I think I've said my piece. The rest of the class, I guess, just work. Got another half hour or so. So you have the packets in front of you. I'd say that's really going to be the best thing to do, to go through that packet, go through those problems. Yeah. Office hours tomorrow. You guys have we have that. So it's office hours tomorrow. And today as well. I'll be here. And one last thing I might be able to do for you guys. Yeah, I think I'll have an opportunity to do that. I could be up late for a Zoom call tonight if you guys want. I could be up around a little bit after 9 o'clock tonight. Would you guys want that? Okay, I could be available from 9 to 10 tonight. So I'll do that also because I could do that for my G period on Thursday night. So okay. All right. So yeah, just have at it. Let's get to work. Yeah.
What is the piecewise function with inverse mean?
So if you look back at your old test, I gave you a piecewise function, you had a graph, and then you had to find the inverse of that piecewise function just by switching x and y and then graphing that. Yeah.
Wait, you want to go to and like equation?
No, because those weren't really that like a 10-point question. So yeah. Yeah, it's something I should have been doing anyway. Earlier this year, I just didn't. But in Algebra 2, we do it all the time. We always go back and look at old stuff. I'm not sure if Japan did that, but I did an at-level Algebra 2. So okay. I think that's, let me save that. That's, and let me save the next one as a PDF. Cool. And stop recording.